Good afternoon, everybody. Welcome to the IAC Acoustics Barrier Walls and Outdoor Noise Control Systems webinar. My name is Ryan Wheeler. Today, we're going to talk about a few things related to barrier walls and noise control systems. We're going to give a brief rundown of IAC Acoustics, our company, and our background. We'll talk about some product features and performances, some noise control screen wall applications and lessons learned. And then throughout the presentation, feel free to type a question into the question feature on the GoToWebinar pop-up. If I see a question, I will be sure to address it. If I happen to miss the question, I will look at the end and see if I can't answer it at that time. If there's any questions I can answer, if you put your email address and contact information along with the question, I can get you the information and send it to you via email. So a little bit of our background. IAC Acoustics was founded in 1949 by a man named Martin Hirschhorn. Mr. Hirschhorn, he started on Jackson Avenue in the Bronx, and he worked his way up to Commerce Ave, where he built his acoustic laboratory. He sold the business in 1998 and remained the CEO until 2001. Today, IAC Acoustics belongs to Catalyst Acoustics Group, which is the parent company of several sound control companies. The director of IAC is Thomas Hines. He started here. He started with IAC back in 2001. Tom has over 20 years of experience. He's been an installer, he's been in sales. He's a very valuable resource to the team here at IAC Acoustics. As I mentioned before, I'm Ryan Wheeler. I am the commercial industrial sales manager. I'm relatively new here at IAC. I think I'm right around 18 months now. I joined the team here in August of 2020. I spent 14 years in the military, and most recently I spent just under 10 years as a site lead and operations manager for a private defense contractor in Afghanistan. I spent the bulk of that time traveling back and forth between the United States and Afghanistan. We were providing intelligence support to the military, wildly different than what I'm doing here, but I do enjoy what I'm doing now for sure. Ted Marquis, he's our industrial sales manager. He's got 20 plus years of industry experience. He does mostly the in-plant noise control, find a problem, fix a problem type thing. Our HVAC sales manager is Darren Riley. He has over 15 years of industry experience. And Andrew Pulte is our NVH and testing facilities sales manager. IAC Acoustics Noishield outdoor barrier systems shield people from loud equipment and transportation systems by forming a screen that blocks and absorbs sound energy. The noise source can be anything, electrical equipment, anything from transformers, rooftop, ground-mounted HVAC equipment, or transportation systems such as highway or railways. On the screen here, we have on the left, there is a ground-mounted barrier wall. In the middle is a rooftop barrier wall, and then we have a barrier wall on the right that is shielding the noise from a road, from a residential area. This slide here is not to insult anybody's intelligence, but if anybody is on here that doesn't have a background in acoustics or anything like that, basically you have this noise source on the left, which is the car in this case, and the receiver on the right, which is the house. And so basically the screen walls or the barrier walls block the direct sound of the path. It forces the sound to follow a path with a sharper angle across the top of the barrier, which means more sound attenuation. There's a few factors that go into the height of the wall. So basically the proximity of the wall to the source or the height, can vary depending on what you're trying to achieve. We'll talk about the basic products we have within the outdoor barrier product line. So basically the first one we'll talk about real quick, and we'll go into more detail in the following slides, but we'll just do a quick rundown on this slide. The most basic panel that we have is the Noishield FS, which stands for freestanding. That's the panel that you see here in this drawing. It's a 5-inch thick panel. We have two sizes, 18 inches and 24 inches. We'll get into some of the panel construction details in some following slides. We also have a Continuline panel, which is basically a Noishield FS panel like you see here, but it has a custom end cap, which conceals structural elements and has a more aesthetically pleasing, it's more aesthetically pleasing. It has the reveal on the structural elements is smaller, and it's just a little bit nicer to look at. The Noishield SFS is a 5-inch thick panel just like this, and there's a steel septum in the middle, and instead of having one side with absorption and the other side is a solid piece, it has absorption on both sides. The Noishield FST is a 5-inch thick panel with enhanced frequency transmission loss. There's more mass on the inside of the panel. And then we have a Slimline panel, which is 2.5 inches thick, and it's surface mounted. So essentially, it's a half of an FS panel with a flat back, and that is surface mounted. And I'm saying surface mounted as it's different than these other panels, and I'll explain why in the next few slides. All of these panels are available in steel and in aluminum. Some performance data here. This slide shows that our performance for transmission loss varies from STC 30 up to STC 33, and our noise reduction coefficient ranges from 1 to 1.05. So what makes IAC superior to the competition? This is kind of a wordy slide here, but I'll briefly touch on some of the important points here. Roll-formed panel construction, we do this for a few reasons. Along with the general efficiency, the roll forming enhances the quality and prevents oil canning. Oil canning is something, it's the appearance of some distortion when you're looking at the surface of the panel and the reflection of the light off of the surface. Kind of gives a bumpy, it's not a very nice smooth finish. We also have a weather shedding design on these FS panels, the 5-inch thick panels. The top portion is slightly pitched, which kind of sheds the water if it was exposed to rain or any elements. And then we have perforated bottom surfaces on the panel, which allows any water that may get inside to drain out. We use G90 steel, which is unique to IAC, and we actually pre-paint the G90 after it is button punched, but before we put the fill in. So basically we take the two roll formed pieces and we button punch them, and then we paint the panel prior to putting the acoustic fill inside. This allows us to put paint on all surfaces. Some of our competitors, they will assemble the panel first, including the fill, and then they'll paint the outside, which means that the inside of the panel it doesn't have that extra layer of protection and could potentially start to rust sooner. Another important thing to keep in mind, I mentioned that our panels are button punched together. We don't do any welding with these panels. So this is important to the longevity of the application. The button punch and the ability to put these panels together without welding, basically regardless of how well you finish the steel after the weld, it'll rust. So you're basically burning off the galvanization when you weld the panels together, and that also will introduce the opportunity for rust down the road. We have our vast color selection. We can match any color. We do have the standard RAL colors, but we can match if you have a specific color and you want to send us a sample, we can match it. It may affect the lead time and the cost slightly, but that is a capability that we have. The double roll formed components provide really good structure, allowing us to go up to greater lengths. So right now our maximum length for this FS panel is 20 feet. And of course that is contingent on approval from a PE and wind load requirements. So as you can see here, this is our FS panel. This is our standard barrier wall panel. A couple of the things that I mentioned in the previous slide, you can see a little bit better here. You know, we have 18 inches and 24 inches nominally. It's a 5-inch thick panel. I spoke about the weather shedding design. So this top surface here on both sides is slightly pitched. So if there was any water that was going to get onto the top of this panel, it would roll off instead of collecting on top and staying there. We do have the margined perf. So this top piece, when I say margin, this top piece is solid, and then the entire backside is perf. This is actually a solid corner as well. It doesn't really show it here, but this is a solid corner that allows us to roll form this piece. And then it goes back to a perforated section along the bottom. And again, that is in the event that any moisture gets inside, it's able to drain out through the bottom. Here you can see an example of a standard FS panel in a rooftop barrier system. The bottom right picture here kind of shows the structural elements. And this is, I told you that I was going to explain how the Slimline panel was surface mounted. These are freestanding. And what I mean by freestanding is that these W beams, as you can see in this picture, are set in place, and the FS panels just slide down inside of the webbing of the beam. And they basically just stack one on top of the other. So they're captured inside the webbing of the beam, and they just rest on top of each other. Typically, we would use, so that, you know, the type of structural elements depend on the, you know, the structural requirements that are set in place by a PE. But typically, we would use like a W6 beam, and being that this is a 5-inch panel, it slides nicely inside of that 6-inch pocket. If we had to use a more robust piece of structural steel, you can weld some angle iron inside of the pocket of the post to create that 5.5-inch or 6-inch pocket that the panel can slide down inside of. And you can see that here, some angle iron welded onto a corner piece. Okay, so yeah, so we have this rooftop barrier here, and with the standard FS panels, you can see all the structural elements are exposed. Now, you know, that doesn't look terrible. It doesn't look bad at all. We match the paint on the panel to the paint on the beam or the post. And you know, it's a pretty good looking barrier wall, but there are times that customers may want something that's slightly more aesthetically pleasing. And in those cases, we designed a special panel with a special, it's actually not a special panel, it's just a special end cap. So our Continuline panel is the same panel construction as the FS panel that we just saw. It just has a custom end cap that wraps the outer flange of those posts and hides the structural elements. So this was a BMW plant. This was the first job that we used our Continuline panels on. So this customer, they wanted a barrier wall around some rooftop equipment, and they were looking for something that was a little bit, that would match the exterior of their building a little bit better. So they didn't really want the structural elements exposed. And that's where we designed the custom end caps, and this was the final result. Looks pretty good. And this is a detail of what that end cap looks like. Basically, the end cap on the standard FS panel, it gets swapped out with this custom end cap, and you can see here how it wraps the flange of the beam or the post. and the reveal is much smaller on that structural element. And these also just slide in from the top. The installation process is very similar. It's just instead of being inside the pocket, it wraps that outer flange. This is a recent job in New York City. This is a rooftop barrier wall with the Continuline panel. As you notice, you cannot see the structural elements. This corner piece is actually this isn't finished yet, so there would be a piece of flashing or some steel detail that would kind of close off this corner piece here. But you can see the rest of the wall on the panels looks really good. I think I visited this job site in July of this past summer and got some pictures. So here you can see, you know, there's we have the ability to mix and match with some louvers. You know, there's a lot of times there's requirements for some airflow. In those cases, we can provide louvers in conjunction with our barrier panels. This is just another Continuline application. It's a rooftop barrier. Again, the structural elements are all concealed. This kind of shows some of the things that we can integrate into the barrier wall. We can have doors, electrical lights, you know, outlets, things like that. This picture shows a close-up of that end cap detail, and it shows, so you have the post here, and the end cap is kind of wrapping that outer flange. And this is a view from the inside. So here we have the flange on the post, and the Continuline end cap wraps it tight, you know, pretty nicely. This is not a fastener for the panel. I think this was for a grounding wire or something, but this is not standard with, you know, with our panels. This is not anything that holds it in place or anything like that. So this is another Continuline application, but this just shows how we have a lot of times we have penetrations that are going to be needed, and this can be achieved by, you know, using panels or steel flashing that ISC can pre-cut before the powder to ensure no lack of aesthetic performance, or in certain cases it can also be cut in the field. This is the Slimline panel that I referred to earlier, and you'll notice that this is a 2.5-inch panel. And you'll see this is roll formed, and this is essentially half of an FS panel. So rather than attaching another 2.5-inch panel to this and then button punching along the edge, we just roll form one side, and then we take a piece of perf or steel, and it actually gets riveted. You can't see the rivets, but it gets riveted along the edge here. The performance data for the Slimline panel, STC 30 and an NRC of 1.0. This is an extreme close-up of our mounting detail for the Slimline panel. This is a piece of structural steel or tube steel, and the Slimline panels, basically this is one panel here and this is another panel, and the flange overlaps on the two panels, and then it gets connected, attached to the whatever structural or substrate they have in place. Here's another picture of a Slimline application. So one thing that you can keep in mind, so this one has the outer part of the panel as a solid piece, and then the inner part is perforated. Depending on what the design is and how the application works, we can use a piece of roll formed margin perf on this side and put a solid piece on the back. So there's Slimline and there's reverse Slimline. Like I said, depending on the application and what the performance requirements are, we can switch the perf and the solid, and that doesn't affect the acoustic performance. So there's some steel detail that goes along with the Slimline panels. So in between stacks of panels, so here's a panel here on the left, another panel below it, and then there's another stack of panels adjacent to it. Now we can use a piece of hat channel in between those panels. So I don't know if anybody noticed this, but the Slimline panel, I'll go back a couple here. The Slimline panel does not have an end cap on it, so it has an open end. So we use a steel detail, a piece of trim basically to close off the ends. So on the end of the stack, you would use a Z channel piece of trim, and then in between the two panels, you would use some hat channel. And this is another example of a Slimline application. Here we have the back of the panel as the perf, mounted to some tube steel. This is an interesting picture here, and this kind of shows a couple of different things. So the barrier wall on top of this building here, I believe that this customer initially was looking for FS panels, and if you remember with the FS panels, those slide in from the top, and because of this overhang here, we weren't able to accomplish that installation method. So what we did instead is we suggested a Slimline panel, because we could surface mount it and that overhang of this building wouldn't be a factor. So one thing that we can do is if we wanted to, we could have, several spans of FS panels, and then, in a spot like this, we could use one span of Slimline panels. We can mix and match. This particular customer actually just decided to go, instead of using FS panels and these other spans, they just decided to go with the Slimline panel for the entire project. But there's some versatility that is added with the Slimline panel being surface mounted rather than sliding in from the top of the posts. This is a slide that just kind of explains what the range of scopes that we can provide. IAC can provide, and with every single job, every customer is different. There's different requirements. Sometimes they want, just the panels, and we can do that. We can supply just the panels and the components. We can supply the structural support. We've the W beams. We can supply the anchor bolts and the cages. We can add PE design engineering to get stamped and sealed drawings from a professional engineer. We can also provide delivery and installation. So you can take your pick. It's kind of a la carte. You can get everything. You can get just the panels or any other combination of these things. So we have just a few more examples of some barrier wall applications. Again, I mentioned ground level or rooftop, HVAC equipment, any machinery, transformers, pumps, valves, generators, you name it, it's making noise, we can put a wall up around it. Rooftop applications, oftentimes, especially in New York City, we've done many projects in New York City. There's a noise ordinance in New York that they moved all of their HVAC equipment up to the rooftops, and then with the noise ordinances, we've had to build several barrier walls around HVAC equipment. A lot of times, I mentioned before, we can incorporate some acoustical louvers into the barrier walls, or sometimes just a small gap like you see in this top right picture. A small gap is sufficient in order to get the required amount of airflow through the equipment. On this bottom left here, I mentioned earlier too, we can incorporate some man doors. The standard man doors that we offer in a typical barrier wall application have an SCC of 33, which basically matches the performance of the panel, so you don't lose any performance by adding a door. This is an interesting project that we did for a transformer substation. I think this one was in Connecticut. This is Northeast Utilities. They didn't want any new foundations. They didn't want any structural elements going to the ground. They had these existing walls. So basically what we did is we cantilevered the entire system off of the face of these walls. This is just an example of the capability that we have to assist in the engineering process and the design process from start to finish whenever you might have unique or complex conditions at the job site. A few more pictures and examples of barrier walls. These are along transportation systems, roadways, railways. This is outside of an airport. And this is just another example of in Pasadena, California, along a rail system. This particular application has a special powder. It's an anti-graffiti additive that's added to the powder coating. This is not standard with our powder coating process, but it is something that we offer. And this basically, the anti-graffiti additive makes it easier. The spray paint or any type of graffiti on these walls is whatever that additive is, it allows it to be cleaned off relatively easily. That is about it. So thank you for joining me today. I know everybody's busy. Here's my contact information. rwheeler@iacacoustics.com is my email address. If anybody would like a copy of this presentation or if anybody has any specific questions, I'd be happy to discuss them with you. You can either email me or you can call me. My cell phone is 413-537-1616. Again, any questions related to any products or any specific project questions, anything like that, I would be more than happy to take some time and discuss them with you. So again, thanks for joining, and I hope you have a great rest of your day.